This session will deal with how to convert a decimal into binary. So for this process, we have got binary into decimal. So in this case, we have a particular formula for doing this conversion process. So if the binary number is 11110011, and from the extreme left right corner, we have to take each of these letters, that is the one, first one being 1, we have to multiply the 2 to the power 0. Then when the next coming 1 will be multiplied with 2 to the power 1, and the next coming 0 will be multiplied by 2 to the power 2. And this sequence will follow as such, like the next 0 will be multiplied with 2 to the power 3, and the next 0 will be multiplied with 2 to the power 4. So this process will continue like this, and the next one coming will be multiplied with 2 to 5, and the next one coming will be multiplied with to the power of 2 raised to 2 to the power of 2 raised to 6. Then when it reaches 7, there's no more multiplying factor over there with this, because there's no more letters. It'll stop over there. So this particular arithmetic count of multiplication with addition should have to be carried out to get the decimal equivalent of this particular binary number, that is 11110011. So this has been obtained by putting into while counter, where the iterator value starts for the when the binary has been considered, that is not equal to 0, and there's an iterator I is been inserted to 0, that will be taking of the iterative value of the multiplying factor of the I multiplied with the factor of 0 to the power 0. So here this will be the multiplicative factor that's happening. Initially the decimal number decimal equivalent is 0, then that has to get multiplied with the binary number, the modulus of 10. That is, this particular statement is extracting the last letter one by one in sequence, and that is being multiplied with 2 raised to power 1, 0, and so on. So first factor, when it's 1 here, it will multiply with 2 raised to 0, and the resulting outcome will go into the decimal number. And the next, there is an iterator working I plus plus, so making the I value 2 in this case. So the 2 raised to 1 will has to get, because 0 will take the value 1, hence 2 raised to 1 will has to be get multiplied with the factor of the next one here. So in order to get the next one here, we have to multiply the whole of the binary number by 10. So the successive multiplication of this 10 with the modulus of 10 will do the successive operation of replacement of the last digit with the obtaining of the resulting numbers. So 1 has been replaced, we have to get back this much factor. That will be done by the binary by 10. And again, the modulus division work to extract the last digit, that is second number. Second last digit will be done by the binary by 10. And to obtain the resulting number after the modulus process being obtained is done by this process to be obtained is done by the binary by 10. So again, to dropping of the 0, we have to use the binary by modulus of 10. And here to obtain the number after the 0, 1, 1 has been discarded, that is 1, 1, 1, 1, 0, to be obtained, we have to, the binary by 10 will be doing it. Division by 10 will be doing it. And the respective multiplication of this process will be done by the this statement over here. So this process is done by this statement, iterative count of 0 to till that number 7. I to 0, I start with 0 till reaches number 7 will be done by the iterative work, where I is initialized to 0. And in order to obtain the last digits of this binary number, binary by 10 will be doing, in order to get the resulting number after the last digit is obtained, is done by the binary by 10. So these three processes goes hand to hand respectively. And once that has been obtained, the resulting decimal number will give the summed form of each of the whole of the step. This will be giving the output as the resulting decimal number here. So this is the output of the resulting decimal number. So this is the one that is obtained here. So this decimal number is nothing but this whole process over here. So once that's been done, we have to the whole of the process is actually happening after the while loop makes an exit. When the 7 reaches 8, there is no more of this particular operation happening here, and it while loop makes a final exit, and the decimal equivalent will be getting confirmed, will be replaced over here. So now we can go for start button, go for debug session of the page, where exactly we can get the output. So here we can see that math power has been utilized for the particular purpose of the multiplying factor of I with 2. So now we can go for the debug session of the page, where exactly the debug output is available. Now we can see that the decimal equivalent of this that particular number of 111100111 was 243. That is 111100111 equivalent was 243.